Hi, welcome to lesson number 4, module 7 of the Apache Spark and Scala course. So in this particular lesson, we will be introducing the MLlib libraries in Spark. So to recap, in the last lesson, we have learned about unsupervised learning and the workflow of an unsupervised learning and what exactly is reinforcement learning. So in this particular lesson, we'll be introducing the Spark MLlib, the benefits of the same, and some supported algorithms. Now, if you look at the Spark stack, we are aware that we have core Spark, and we have already seen the Spark SQL and Spark streaming. And the third library is called MLlib. This is the library which supports machine learning in Spark. Like I said, MLlib is Spark's machine learning library, and the idea behind MLlib is to make practical machine learning scalable, easy, and faster. Now, the MLlib library supports a wide variety of algorithms such as classification, regression, clustering, so on and so forth. Now, what exactly are the benefits of MLlib? First of all, it is built on top of Apache Spark, which means it is very easy to program. You don't need any third-party utilities to do that. Second, it is scalable. Since Spark can serve as a point of storing terabits of data, you can analyze the same using MLlib libraries. And the third and most important point is the language APIs, which are Python, Scala, and Java, and even the R library. It provides a broad coverage of application and algorithms and rapid development in speed and robustness. Now let's have a look at some of the supported algorithms in MLlib. So there are a wide variety of algorithms supported, such as classification, regression, recommendation, clustering, frequent item sets, feature extraction, statistics. It also supports linear algebra, model import-export, pipelines, data frames, and cross-validation. Now, when we look at classification, like we have seen in the earlier slides, Spark's MLlib supports the classic logic regression and SVM and naive Bayes. And the regression, we have generalized linear regression. And for collaborative filtering, it supports the alternating least squares algorithm. Now, when it comes to things like collaborative filtering, it is very much used for recommendation engines. And the most widely used algorithm is ALS, which is supported by Spark. And if you look at clustering mechanisms, it supports the native k-means. And in decomposition, we have singular value decomposition, which is SVD, and principal component analysis called PCA. And what are some of the supported classification algorithms? So we have logistic regression and linear SVM, decision trees and random forest, gradient boosted trees, naive Bayes, and multi-layer perception. And inside the regression category, we have least squares, decision trees, random forest, gradient boosted trees, isotonic regression, and streaming least squares. And when you look at clustering, like we have seen just now, it supports native clustering. It also supports k-means, streaming k-means, latent, Dirichlet allocation, and power iteration clustering. And when we are looking at feature extraction, transformation, and selection, there is a wide variety of algorithms supported, such as binarizer, bucketizer, count vectorizer, element-wise product, hashing term frequency, n-gram normalizer, vector indexer, vector slicer, and word-to-vec. And when we move towards the statistics algorithms, we have Pearson correlation, Spearman correlation, online summarization, chi-squared test, and kernel density estimation. And like I said, under recommendation, we have ALS. We have already discussed that. And frequent item sets, we have FP growth and prefix span. In linear algebra, local and distributed dense and sparse, and matrices and matrix decomposition. Now, you might be wondering why I'm not going into the details of these algorithms. And the simplest answer is it is not required unless you are a data scientist. Now, when somebody takes up a Spark and Scala course, the idea is that you should be aware of the capabilities of Spark. For example, when we look at MLlib, Spark can do machine learning, and machine learning itself is part of data science, which means if you're working as a Spark developer, chances are high that you might encounter a project mate who is working on a very crucial data science or a machine learning problem, and he might come up to you to ask for help with any of these algorithms. So you need to have a broad idea as to these are the supported algorithms, and how to implement them and how to build your model, that is a call that the data scientist team has to take. And in case if you are a data scientist, then I request you to specialize in the Spark MLlib course. So to wrap up in this lesson, we have learned the introduction to the Spark MLlib libraries, the benefits and the supported algorithms. That's all for this lesson.
If you have any questions, please do not hesitate to raise a support ticket. Thank you.